What's our first even, cool kids? Oh, it's right there. Oh, because of this here. Got it. It's on the front table. That one. Oh, got it. Sorry about that. Okay, number 6, final answer is 1/2 arctangent of x minus 3 over 2 plus c. Plus c. Looks a lot like some of the ones we did. Anyway, what's the number next one? 14. Thanks, guys. 14 is over here. That's kind of weird and awkward. -1 over rad 7. Totally fine. You can rationalize whatevs. You end up with arctan cosine x over rad 7 plus c. I love this answer because you guys should have been able to quickly make it match with that answer if you needed to. Couple more seconds. What's wrong? How to be rad 7? Because remember, a is squared, so we have to square root the number that's there, right? Right? It's a squared plus u squared. Who is squared? Root 7. Does that make sense? Oh, they're rationalized. Here, guys, all they did is multiply by rad 7 over rad 7. Multiply by rad 7 over rad 7. Oh, where the negative came from? If u is cosine, du is negative sine, right? If u is cosine, du is negative sine, right? Ah, see, that's just du. Now, remember, they do their u sub weird. It should be du over negative sine. The signs cancel, the negative comes out, right? They show theirs differently. But with ours, we would have plugged in du over negative sine, signs cancel, negative pulls out. We have 7 plus u squared. We need a squared, so a is rad 7. Sorry, I had people over here asking about the 7. We had people over there asking about the negative.
It's like already in the right form.
We need a squared plus u squared. Does that make sense? Yeah. So it's not the right form unless we have either a 1 or unless we have, or see it as an a squared. Does that make sense? Yeah. Cool. We're on 14, Bridget. The only one you missed, I think, was number 6. If you have it open, number 6. And there's number 14. All right, kiddos, let me know where I'm headed. 24? Okay. Oops. He's over on this side. Final answer, pi over 18. Final answer, pi over 18. You would have had to go to your unit circle. Maybe you have a decimal? Maybe you have a decimal, but remember, if it was a decimal, we wouldn't have shown any of this work. Pi over 18. Number next one. 40. Final answer, arcsecant of absolute value. Ooh, we didn't write that in our formula, did we? Arcsecant of absolute value of x minus 1 plus c. Oh, praise the Lord, iPad's alive. Okay. Number next one. 74. If you go double check our formula, I don't think it's an absolute value of arcsecant. I apologize. Ooh, 74 has some fun stuff going on. We have pi, and then pi, and then pi. All three of them are pi. I think you were supposed to figure out which one is pi, isn't that right? Something like that? Yeah. 1, 2, and 3. All three are pi. Number next one. Oh, look at that. With that, kiddos, let's go ahead and I'm going to call back groups in just a second because a lot of you guys seem like you tried to get this done because you wanted a full credit on the homework check. That's a great idea. So let me get you that full credit. But I want you guys to have that worksheet out because as I'm calling you guys back, I'm going to make sure that we're using our time productively, huh? This is homework number 32, right? The last homework, just kidding, almost the last homework before a test. What's the last homework you guys need to be working on tonight and tomorrow? Test review. And then technically the worksheet, it's not a homework number, but whatever we don't get to finish will be homework for tomorrow. Test is when? Thursday. So we also have tomorrow. Today we'll work on the worksheet. Tomorrow we'll work on the chapter review questions you have and maybe a few particular problems I'll throw you. Not in a mean way, more of like a softball lobbing way. Yeah, and forever quiz is tomorrow if you guys look at the backboard. But it's only on cards what to what? 43 to 45, and they're just formulas. Today's the 14th formulas. Alright, let me pull up notes because we need to go check out why there was that silly absolute value thing for arcsecant. I don't know why I didn't have it written in the formula sheet. Oh, stink. Hold on. I haven't turned on my... Alright, so keep your homework turned to 4.7, but as we were talking about, grab out your equations and change worksheet. Oh, thanks, Brandon.
Can you show me the quick one here that you I think it's probably into the
Whenever you have an answer. Yeah. Actually, I'm getting you guys going on the integration. It's not thinking about this one. But I will in a second. Try and get my notes up there. There we go. Yeah. Can you still get out?
Yes.
Alright, kiddos. As you noticed with arcsecant, there was an absolute value we think about. That's my bad. In your forever card, that was my bad. There should have been absolute value on arcsecant. Arcsine is fine and arctangent is fine. Arcsecant, though, needs an absolute value. Long story short, square root of a squared, that's kind of the reason why. I apologize, I don't know why I put parentheses whenever I wrote this a couple years ago. But there should be absolute values instead. Let me try to make this a little bit nicer and neater and clearer. Stink. I'm going to try and change it on the Forever Card online, kiddos. Today is a very busy day. This week is a very busy week. Is anybody else doing that? Is that just me? Oh my goodness. So I will try to change it online, but if you guys make sure to change it now in your Forevers and or in your notes. Arcsecant should have an absolute value. I apologize. There we go. Alright, kiddos. We got here yesterday, right? That was number 3. Now hold on, pause. You guys have your worksheet now. Number 1. Do you want to fill in the work real fast? Remember, this worksheet is due completed tomorrow.
Oh, what?
Whatever we don't get done today, we're going to work on as much as we can. And maybe I'll narrow down a little bit. But especially whatever we get done in class better be done and then some extra. We have 40 minutes almost. We'll try to use it to the best of our ability to bust through these. You guys have a calculator. And why was it 3,600? Because there were approximately 12 of these squares. And why were we doing area under? Because if we're going from rates being pumped to total gallons being pumped from one time to another, from 0 to 24, we need area under. To go from gallons per hour to gallons, we need area under. Integral, but we can't, so we'll just go with approximating area. Why isn't it showing up? No, why? Oh, because it's frozen. There we go. Alright, you guys got number 1 down, okay? Alright, let's get to number 3. This is the one we were looking at yesterday. Don't worry, we're going to do a homework check. I'm trying to get you guys going on some stuff to be productive. Number 3, we looked at it fast. Why do I have an integral written? The rate at which customers arrive at a counter is modeled by function. Which function? This function. In between 2 times, 0 to 60. Measured in customers per minute. To the nearest whole number, how many customers arrive at the counter over the 60-minute period? Here's the question. I'm going to try to word this a little bit better than yesterday. Is this asking for how many customers are currently in the restaurant or in the restaurant at one time, at a certain time? How many customers are in the restaurant at a certain time? Or how many customers arrived over a time interval? Which one? At a certain time or over an interval? Good, over an interval. So if we have customers per minute, And if we want customers, we know we have to integrate, of course. But if it's over a time interval, all we got to do is think of, in a sense, displacement. Just integrate from 0 to 60 and say, okay, we need to accumulate all the customers that arrived. And how do we do that? We take the integral of the rate, which is customers per minute. Now, why did I just say, hey, you should find the answer, no work involved? Calculator, ready, set, go find me an answer, go. Can you use your calculator to integrate? Can you use your calculator to solve a definite integral? Ooh, make sure you're in radians. If you loaned your calculator to a pre-calc kit, they might have changed it. Group 1, point towards me, you're 4-7. Okay. Carolyn, do the second page. Yeah. How far did you get? What number? Okay, I'll give you a 4.
I don't know.
Group number
How do you get
2, let me see.
How do you get the angle?
Math, and then you want function integrate. FNINT, sorry. 359. How far is it? Okay, I'll give you 3 out of. You finish it, I'll give you another point. Same with you, Caroline. Finish it, I'll give you half the point. So half that. Thanks, baby. Yeah.
How do we know what we're going?
Still use function integrate. I got it. But hold on. Older calculators. When you do function integrate, it doesn't give you the snazzy function, right?
Yeah.
So what you want to do is Fn. It shows you this. True.
Yeah.
Then you want to type in the function. Put it in terms of x. Put a comma. Put an x. Put a comma. Put a 0. Put a comma. Put a 60. Very similar to derivatives, but you need 2 commas to do the 0 and the 60. Does that make sense?
Yeah.
So put in your equation.
Yeah.
Oh, okay.
You can use x instead of t, totally fine. But instead of getting to fill in the nice snazzy bounds, you put in your equation, put in your x, put in lower bound, upper bound. Sorry, this is the older way. This is the newer way. And to be honest, older people, like older calculator people, you're literally typing the same amount that the other people are typing. So you're not losing time, you just have to know how to put it in. What'd you guys get? 725?
Yeah.
Everybody got it? Anybody have questions on their calculators? You did 0 first and then 60?
4.6. Yes.
724.
You didn't do negative 12, you did 12 plus? It's equal. There you go. There you go. There. Okay. Let's keep going. Number 5. I feel like we're doing the odds. You guys read and then think. This is a tricky question. You actually don't really have any math to do. You just have to match the concept. Go to number 5. I'll give you a couple seconds as I keep checking. Group number 3. Let me see homework. If you have them. Okay, good. And then they went in the back, right? Cool. Good? Good. Brendan, you don't have a pen? Okay. Group number 4. Let me see. Corey, how far did you get?
Up to 74. Just didn't want to do this.
Okay, you're just good to do. Good, and then Ella, good. 4, 7, 4, 7. You guys, show me yours. Good. Wait, 4, 7.
I'm pretty sure it's 4.7. I think it's 4.
Oh, it's 359. Yeah. Change it to 4, 7.
That's weird.
Star and Josh can show me later for refresher. You guys, let me see. Ryan's group. And then Alan's group. Charlie, I saw yours. Alan pulling up. I saw it then. Good. What do you got? That's 4, 6?
Yeah.
So question, guys, who is R?
Yeah.
Who is R? Million barrels per year, right? We have million barrels per year, right? What are they asking us for? In between 0 and 10. Okay, is it at one time or is it over an interval? And we're going backwards from rate to amount, which means we need a integral. So what did you guys choose? D. D. We did not need a prime because we already had a rate. We did not need a prime because R was a rate. So to go from million barrels per year back to millions of barrels, it's like going from miles per hour back to miles. All we have to do is integrate once, one jump. One jump. How are we doing? Okay. You guys see how this is very concepty? Okay. Number 7. Ooh, life just got exciting. Because this is what's known as an FRQ. Ryan Murphy's not here for an FRQ. It's the microphone. Don't pull it out. Just hit the little button and see if Ryan texted. Email.
No.
Okay. Yeah, I know it's like 5 minutes. I just want to make sure it's alright. Okay, the rate at which. Okay, hold on. I already know what this question says. I've gone over it for like 7 years now. So question, I don't know. It's been a few. Can you guys just read it real quick? Read it all the way up to A. If I were you, I would star the important stuff they give you. Maybe like underline any units they give you. Let's see how far we get. Bridget, was it traffic or was it something? Okay. Every minute but Ryan, right? You guys get in the scenario, people are coming in and people are coming out. But what did they give us equations for? How many people or how fast? How fast. The rate at which people come in and the rate at which people come out, right? Okay. Now, if I were you, if I were you guys getting ready for this problem, you could almost figure out that you're going to use both of these equations, the E and the L, and you could almost say, hey, let's just make him Y1 and let's make him Y2. I'm pretty sure I'm going to be plugging him in at some point. What would be the purpose? What would be the advantage of plugging him in Y1 and Y2? You have them in your calculator, and can't you refer to Y1 and Y2, like if you need to do an integral? Or can't you plug into Y1 or Y2 if you need to do like a plugging in sort of thing with function notation? So if I were you guys, right now in your calculator, just go ahead and plug both of these functions in your Y1 and Y2. Doesn't mean we'll use the graph, per se. Doesn't mean we'll necessarily use the graph. But then we can use these functions over and over again if we need to. We can use these functions over and over again if we need to, without having to type them in over and over again. Sorry, I didn't want someone to steal it, so if they do that, then I forget it. Ignore all this stuff. I don't even know what that's from. Now, kiddos, if I were you, remember, it's super easy to make a mistake on fractions. Are you using your nice little fraction-y button? And if you have an old calculator, are you putting big parentheses around the numerator and denominator? Does that make sense, Charlie and Christian? Okay. This is positive 15,600 or 15,600. Sorry, it's an equals before, right, guys? Not a negative. Okay. All over t squared, we can use x, no big dealio. Minus 24t, minus 24x, no big dealio. Plus 160. You guys can always use the alpha stuff if you're like on the home screen, but in the function mode, you always have to use the variable button or else it's going to get lost. And then we can use, once again, our alpha y equals, if I can hit the actual right button, 9890. All over x squared minus 38x plus 370. Okay, now we have both of our functions, and they're in the same order they're listed there, and we can refer to them if we need to. Cool? What does letter A ask for? Well, hold on, we have units. T is measured in hours after midnight. I bet that's important. These functions are valid between, why would they only be valid between 9 and 23? Oh, it's when the park, so the park opens at what time? 9. And before 9, are there any people other than employees in the park? No. Okay. So at t equals 9, the number of people is 0. Okay. How many people have entered the park by 5 p.m. by t equals 17? We need to go from people per hour. Do you guys underline that one too? We need to go from people per hour back to people. What do we need? Integral, from rate to original. We need an integral. Are they asking how many people are in the park at 5, or how many people have come into the park over the time 9 to 17? Over the time. So what are we going to make as our bounds? Who am I putting in my integral? Is it E and L? Nope, just E, just enter. Why is it nice that we have this already in our calculator? Is that Y1 or Y2? Uh-huh. So we can go ahead and just say, sweet, let's go ahead and do math, and then function integrate is what number? 9. And we can go from 9, which is the beginning, not 0, to 17, which is 5 p.m. They're doing a military time, right? And can't we just do, remember how to get to vars quickly? We can use vars and over for those of you guys with older calculators. Vars, function, y vars, enter. There's y1. But for the rest of us, what's the shortcut? Alpha y equals, and you end up hitting the trace button, right? Y1. And then everything's in terms of x. All you gotta do is type it in, and they say round to the nearest. We're like, sweet, we can round to the nearest. 6,004. That's it. They said the nearest person. No half people. Or 0.27032 fourths of a person. Oh, alpha. You can go alpha y equals. There's all your menu and then hit trace. Or you can just hit alpha trace because you know where you're going. Okay. So we have 6,004 people. Make sure you always, always, always label, yeah? They didn't say anything about explain, so we'll just say whatever, you know what I'm answering. Done, Dylan, done. Hey, you just got 1 to 2 points of a 9-point FRQ. Oh. Go team. Yeah.
Divide by 0 error.
Divide by 0.
It says
Check the function.
Check your function. Yes, something went wrong. And you're typing into the function probably. You got it? Okay. Letter B. The price of admission to the park is $15 until 5 p.m. Well, this would be nice if parks did this. A discount if you go in after a certain time. Anyway, price of admission to the park is $15 until 5 p.m. After 5 p.m., it changes to $11. Okay? How many dollars are collected from admissions to the park on a given day? What do you think, Katrina?
Take the integral of the entrance from 9 to 17 and then another integral from 17 to 23, and then you have the amount of people, and then you multiply it by the number of cost.
How much did it cost for all of the people entering between 9 and 5?
15.
$15. So we can say $15 per person, right? Does that make sense? The integral finds the number of people coming in, multiply by 15. What are we going to do between 17 and 23? Multiply by $11.
Christy?
Yeah.
Brian's at home said, like, there's an unfortunate series of events that ultimately concluded within the state, or going back home.
Okay. Let them know we're thinking of them. Just checking. Hey kiddos, can we do this whole thing in our calculator? One input? Oh yeah. So let's go for it. 15 times. You guys see how by having that function we don't have to type it in over and over and over again? It's pretty nifty for calculator problems. Now in the AP they do only let us have 2 FRQs with calculators. However, you use that calculator to its fullest potential. But you write what you're putting in. Now don't write like what buttons you're pushing. That's ridiculous. They're going to get really mad at you. And you're going to waste so much time. But show them the expression you're typing in. You don't have to write the equation over and over again. You can just label it. They're okay. They'll figure it out. Not even will they figure it out. The person who's grading it is specialized on that question. They have that thing memorized. You're good. You have 17 to 23. Look at that. Type it in, we do it correctly, and we get our answer. Pretty cool, huh? 104,000? Is something weird? That's okay. I wrote the 11 next to it. Could have written the time symbol, but it should have matched up with those of you guys that didn't write the 11 next to, right? And they say, how many dollars? What do you think we're going to round it to? The only time you don't round, the only time you don't round to the nearest 1,000 or 3 decimal places is when it's money or when they tell you otherwise. Otherwise, you always leave 2 decimal places. How we doing, kids? Oh, you do want to. So we're just doing it. All right, letter C. Oh, go ahead. Oh, because I rounded since it's money. So I rounded 2 decimal places, and so I rounded up. Ooh, that's a good question. Price of admission. How many dollars you collected from admission? So this has a fractional person. Ooh. A fractional person wouldn't pay. Round your answer to the nearest whole number. Since they didn't tell us specifically to round to the nearest dollar, we'll just leave it and let them interpret. Yeah. Good question, Sarah. But that's very good logic because technically you're right. They couldn't get cents, right? Wouldn't make sense. Unless there was like a tax or something. Okay. Letter C. What? Why are they doing this new H guy and then telling us to tell them what H stands for? All right, hold on. H equals the integral from 9 to t. Doesn't that mean people then? Isn't H finding the number of people? But why are they doing E minus L? Ooh! Say it again, Angela. The total people in the park, because you're taking how many people are coming in minus how many people are coming out for the same interval, and so you're left with how many people are there. Oh. Okay, so hold on. What do they ask us to do? They said, we move our calculator. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the park. Okay, well, Angela just said, if this is people, which we know it totally is, because when you integrate rate, you get back to the normal measurement. People per hour goes back to people. this will leave us with the total number of people in the park. We can say right now, without like making it all snazzy, we can say the total number of people in, I'm just going to put in for in the park. Do you guys remember what's going on at t equals 17? What time is it? Yeah, 5 p.m. Or you could say at t equals 17 hours. 1700 if you want to be super snazzy. So, wait a minute. How do we find h prime of 17? H prime, don't we take the derivative of both sides? Can anybody think of the theorem that lets me take the derivative of an integral? Second FTC. And second FTC says if you take the derivative of an integral, what do we end up with? You plug in the top bound as long as as a constant to a variable, right? And then times u prime. Who's my u? So what are we left with? I'm going to put it such that, oh no, we're just doing h prime of t. So what do I get? E of t minus L of t and all of it times t prime, which is just 1. Because t is a variable, right? T prime is 1. Oh, so how do I find h prime of 17? Yeah. E at 17 minus L at 17. Aw, stink! I have to type all that in my calculator? No. Why? We have it. So all we gotta do is go find our y1. Try to find my y1. Remember, calculator gets function notation. Oh my goodness, there we go, 17. Minus y2, which is the L, right? Of 17. Ugh. Now, if yours does this, it's saying that, hey, you put things in fractions, so I'm putting things in fractions. If you don't want them in fractions, what do you gotta do? Say go to decimal. By using that cool little fractiony thing, they're gonna give you all fractions, which isn't bad. You could write it and be right, but you're gonna annoy some poor AP grader. You can go get a decimal for them, they'll be much happier. And we end up with, yeah, the older probably would, 380.281. Always leave 3 decimal places. What would our units be? That's going to be half the battle. People per. Wait, per. Yeah, aren't these rates? What are they measured in? So now how do we explain it? You say, well, what am I interpreting right now? Where did I get 3,725? I'm just explaining that's the total number of people in the park, right? So there's 3,725. My English people, you get to write a little story. There are 3,725 people in the park at 5 p.m. and the total number of people in the park is decreasing at a rate of negative 380.281 people per hour at that time. Now I made one mistake. What was my one mistake? I'm interpreting, decreasing at a rate of negative. If I'm saying decreasing, I'm interpreting the negative, so should I put the negative also?
No.
No. Why did I say decreasing? Because the rate is negative. If it was positive, I would say increasing at a rate of. At that time means at 5 p.m. Angela.
Do you want to take the derivative of the integral because you're trying to match up the h, or you're trying to, because you know if you have h of t, so you're trying to find the derivative of.
This is h, right?
Yeah.
So if I want h prime, I derive one side, which means I have to derive who he is. Does that make sense?
Yeah.
Yeah, just think algebra on that. You guys got it? Does that make sense, my interpretation, my little paragraph just explaining? Cool. What's letter D ask? At what time t, between 9 and 23, does the model predict that the number of people in the park is a maximum? Brandon, can you grab me a packet when you come back to this? Just from the front. Maximum. Wait, what stands for the number of people in the park? Oh, we just figured this out. H of t. Okay, so hold on. Here's what they're asking us to do. Find the maximum of h of t calculator's in the way. Between, or for, maybe I should do that instead. Oh, little buddy, you're in the way. Don't do that. There we go. Find the max of h of t for t within 9 to 23. How do we find maximums of things? First derivative, how to find relative extrema? We can use the graph. Can we graph h of t? He's the integral. Ugh. Yeah. We're going to find h prime set equal to 0. And then we are going to test t and h of t for 0. Wait, why am I testing 0 and 23 and some unknown people in between? I'm testing for what kind of extrema? Absolute. I'm testing endpoints and critical numbers. How do I find h prime equal to 0? Who is h prime? Didn't we already figure it out in the problem above? Now, if you hadn't figured out the problem above, should you still go to D and write cool work like this, even if you have no clue how to do it? Yes. You can get points for work. Even if you miss a problem above, they still will give you points based on correct stuff shown. How do I do this? How do I find the zeros? Why am I going to my grapher? And why am I going to Y3? And typing things I'm not supposed to type. Oh no, stop. And Y and Y3, am I going to alpha trace and getting Y1 and subtracting Y2? You guys see what I'm doing? I'm putting in and making a third function of E of t minus L of t. Look, I got him, E of t minus L of t. I'm saying forget the rest of the guys. I don't want to see them separately. I want to see them together. So let's get rid of Y2. Let's get rid of Y1. I want to graph Y3, but why am I going to change my window to be between 9 and 23? That's the interval. And why am I going to maybe make the numbers a bit bigger than negative 10 to 10? Didn't we just talk about how at 17 the number was like 3,000 something?
Yeah.
Alright, just to be safe, I'm going to like 5,000. Let's see what we got. Anything good? Ooh. Hey, look. Da, 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 da. 0. Oh, maybe I should have done some more negatives to see what's going on. Hold on. Window. Let's go to like negative 5,000. Da, 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 da. 0. Da, 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 da. Wait, why does it make sense that the rate of people in the park is above and then below? up to a certain time, the number of people in the park is increasing, and then as it starts to get late, what's going to happen the rest of the night? The number's going to decrease, yeah. So you do second trace, we can find our 0 because we're cool like that. We can do the whole like above and below thingamabobber. He's above somewhere. He's below somewhere. Find a 0 in between, please, and they say 15.794. And guys, we could go ahead and figure out what's going on at 0, except, wait a minute. Oh, sorry, at 9, my bad. At 9, we already know that there's 0 people in the park. We could figure out what's going on at 23, just a hint. It ends up being 0 people in the park again. We could technically talk about how the function is strictly above and then strictly below from 9 to 23, so the maximum has to be, the absolute max has to be at 15.794. But they didn't ask us to explain. What they asked us instead is find the number of people. So we've already figured out the maximum. If you want, the sign chart kind of further proves that. But question, how do we figure out the number of people in the park at 15.794? Oh, that's right, because isn't H the number of people in the park? So we're going to find H out of 15.79. Now why am I going to put 4815? Because I don't want to round until the end. So I'm going to do the integral from 9 to 15.794815. Another day maybe we'll talk about how you can store this number in your calculator, which is pretty spiffy. Isn't it technically E of X? Whatever. This is all calculator work, right? You guys actually want to see me store it? Ready? If you leave a graph with a number on the screen that you have found, you can go ahead and hit stow, even though there's all kinds of yuckiness on your screen. You can make it alpha A, and guess what? It says, oh, hey, I get you. You want to keep him. And I say, thank you. And then I can go ahead and just do my nifty-difty little math 9 and go from 9 to alpha A, which I just stowed away to be my 15.794814. Ooh, that's cool. Then I can do my nifty-difty y1 minus y2. Oh, I guess I could just put in y3, huh? Oh well. I just went ahead and, since we did it before that way. Done, 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 done. How many people? Done, done. 3,950. So I'm talking about people. We'll go ahead and just say at what time. And technically, I guess we say something hours after the park opens, or hours after midnight if you want. That'd be the best way to put it. Could probably just split 15.749 hours. Did you guys read the question carefully, which I did not? I guess they didn't actually ask for how many people. Struggle. Oh well, they asked for the time and we found it. Alright, cool kids. Let's get back to our notes. Or our worksheet. So far we have done what? We've done 1, we've done 3, we've done 5, we've done 7. Okay. I want you guys tonight to do the following. You ready? Okay. I want you to do 2, 4. Finish the rest of the multiple choice. So circle 2, circle 4. Circle 2, circle 4. Then let's go to 9. Circle 9. And let's go to 11. That's it. 2, 4. 9 and 11. This topic will be equally covered as the other one. 2, 4, not equally, probably a little bit less quicker. 2, 4, 9, and 11. 2, 4, 9, and 11. That's it for tomorrow. Besides, if I were you, study those forever, study those forever, study those forever. Maybe work on your chapter with you. The other ones will eventually be due. Don't stress about it right now. Focus your attention on what you need to be doing, yeah? Like if we get in a rhythm. We just started. Nutrition will be a little rough.
I just like, my gosh, stuff like happening.
It didn't match. Needs to be like with the formula.
I don't know. I'm gonna work on it.
I'll be here those times.